National Examination of Higher National Diploma 2022 Session. Specialty, Option, Software Engineering, SWE, Paper, Case Study. Section A, Algorithm and Programming. 50 marks. I, Algorithms, 10 marks. Question 1. Explain what space complexity of an algorithm means is. 2 marks. Answer. Space complexity refers to the total amount of temporary storage space required by an algorithm to run to completion. It includes both the input space and the auxiliary space used by the algorithm during its execution. Question 2. An algorithm execution time can be said to be worst case, average case, or best case. Define these notations. $3 times 1 equals $3 marks. Answer. Worst case, the maximum amount of time an algorithm would take to complete its execution. This occurs under the most unfavorable input conditions for a given algorithm. Average case, the expected execution time of an algorithm given a random or typical input. It is usually more complex to calculate than worst case time. Best case, the minimum amount of time an algorithm would take to complete its execution. This occurs under the most favorable input conditions for a given algorithm. Question 3. Write an algorithm that receives 3 numbers and displays the maximum of these numbers using I, pseudocode 2. Flowcharts. Answer. I, pseudocode. Algorithm find maximum input, num1, num2, num3, 3 numbers, output, max_num, the maximum of the 3 numbers, declare max_num if num1 equals num2 and num11 equals num3, then max_num equals num1 else if num2 equals num1 and num2 equals num3, then max_equals num2 else. Max_num equals num3 end if. Display max_num end algorithm. 2. Flowcharts. Since I am an AI, I am unable to draw diagrams. However, I can describe the flowchart for finding the maximum of 3 numbers. Flowchart description. 1. Start. An oval shape indicating the beginning of the algorithm. 2. Input. Parallelogram. Read num1, num2, num3. 3. Process. Decision. Diamond is num1 equals num2. Oh yes. Process. Decision. Diamond is num1 equals num3. Yes. Max_num equals num1, rectangle. No. Max_num equals num3, rectangle. Oh no. Process. Decision. Diamond is num2 equals num3. Yes. Max_num equals num2, rectangle. No. Max_num equals num3, rectangle. 4. Output. Parallelogram. Display max_num. 5. End. An oval shape indicating the end of the algorithm. 2. Procedural programming, 20 marks. Question 1. A class of N students take an annual examination in M subjects. 2 of such subjects are coefficient for subjects and the rest are coefficient 2. Mathematics and English are the 2 coefficient for subjects and they are compulsory. Each student must offer between 4 and 10 subjects. Write a C program that permits the user to I. To enter the number of subjects written, marks on 20 and the coefficient of each of the subjects written. 2. The program will print out the total marks of the student, his average and his remark, $0 equals average $6, $ver rapport, $6 equals average $9, pour, $9 equals average $10, below average equals 10, average 10, good, 10 marks. Answer. I. To enter the number of subjects written, marks on 20 and the coefficient of each of the subjects written. 2. The program will print out the total marks of the student, his average and his remark. C. #include, stio.h. #include, string.h, // for strcmp. #define max_subjects. 10. Int main. Int num_subjects. Char subject_name, 50, float marks, max_subjects. Int coefficient, max_subjects, float total_weighted_marks equals 0, int total_coefficient equals 0, float average, char remark, 50. / get number of subjects do. Printf, enter the number of subjects, between 4 and 10, scanf, %d, and num_subjects, while, num_subjects, for num_subjects greater than 10. / get marks and coefficients for each subject for, int I equals 0, I num_subjects, I++. Printf, \n enter details for subject %d, \n, I+1. Printf, enter subject name, scanf, %s, subject_name. Printf, enter marks for %s, out of 20, subject_name, scanf, %f, and marks, I. / validate marks if, marks, I, 0 marks, I, greater than 20. Printf, invalid marks. Please enter marks between 0 and 20. \n, I, / decrement I to re-enter details for the same subject continue. / assign coefficients based on subject name or default to 2 if, strcmp, subject_name, mathematics, == 0 strcmp, subject_name, English, == 0. Coefficient, I, equals 4, else. Coefficient, I, equals 2, printf, coefficient for %s, %d \n, subject_name, coefficient, I, / display assigned coefficient. Total _weighted _marks plus equals marks, I, asterisk coefficient, I, total _coefficient plus equals coefficient, I. / calculate average if, total _coefficient, 0. Average equals total _weighted _marks, total _coefficient, else. Average equals 0, / avoid division by 0. / determine remark if, average equals 0 and an average, 6. strcpy, remark, very poor, else if, average equals 6 and an average, 9. strcpy, remark, poor, else if, average equals 9 and an average less than 10. strcpy, remark, below average, else if, average equals 10. strcpy, remark, average, else if, average greater than 10. strcpy, remark, good, else. strcpy, remark, not applicable, / should not happen with valid inputs. / print results printf, \n, student results summary, \n, printf, total weighted marks, %.2f \n, total _weighted _marks, printf, total coefficient, %d \n, total _coefficient, printf, average, %.2f \n, average, printf, remark, %s \n, remark, printf, \n. Return 0. Question 2. Write a function named location _of _target that takes as its arguments the following: 1. An array of integer values. 2. An integer that tells how many integer values are in the array. 3. An integer target value. The function should determine whether the given target value occurs in any of the cells of the array, and if it does, the function should return the subscript of the cell containing the target value. If more than one of the cells contains the target value, then the function should return the largest subscript of the cells that contain the target value. If the target value does not occur in any of the cells, then the function should return the sentinel value -1. Thus, for example, if the target value that's passed to the function is 34 and the array that's passed to the function looks like this: 0, 1, 2, 3, 4, 5, 6, 58, 26, 91, 30, 4, 70, 34, 88, then the target value occurs in cells 3 and 5, so the function should return the integer value 5. 10 marks. Answer. C# include stio.h // function definition int location _of _target, int r, int size, int target _value. Int found _index equals -1, // initialize with sentinel value -1. iterate through the array to find the target value for int I equals 0, I size, I plus. If r I equals target underscore value. Found underscore index equals I, / update found underscore index with the current largest subscript, return found underscore index, / return the largest subscript found, or -1 if not found. Int main, / example usage, int r equals 58, 26, 91, 34, 70, 34, 88, int size equals size of, r, size of, r, 0, int target equals 34. Int result equals location underscore of underscore target, r, size, target. Printf, the target value %d occurs at the largest subscript, %d \n, target, result, / expected output, 5. Int target underscore not underscore found equals 100, result equals location underscore of underscore target, r, size, target underscore not underscore found. Printf, the target value %d occurs at the largest subscript, %d \n, target underscore not underscore found, result, / expected output, 1. Return 0. 3. Object-oriented programming, 20 marks. Question 1. Define the following as seen in object-oriented programming. $3 times 1 equals $3 marks. I, object 2. Classes 3. Methods. Answer. I, object. An object is an instance of a class. It is a real-world entity that has state, attributes or properties, and behavior, actions or methods. Objects are the fundamental building blocks of an object-oriented program. 2. Classes. A class is a blueprint or a template for creating objects. It defines the structure and behavior that its objects will have, including attributes, data members, and methods, functions. A class itself is not an object, it's a definition. 3. Methods. Methods are functions or procedures that belong to a class or an object. They define the behavior or actions that an object can perform. Methods operate on the data, attributes, of the object they belong to. Question 2. What are the 4 major principles that make a language to be object-oriented? For marks, answer. The 4 major principles that make a language object-oriented are: 1. Encapsulation, bundling data, attributes, and methods, functions, that operate on the data within a single unit, class, and restricting direct access to some of an object's components. 2. Inheritance, a mechanism where one class, subclass, derived class, can inherit properties and behaviors from another class, superclass, base class, promoting code reusability. 3. Polymorphism, the ability of an object to take on many forms. It allows objects of different classes to be treated as objects of a common type, often achieved through method overriding and overloading. 4. Abstraction, hiding the complex implementation details and showing only the essential features of an object. It focuses on what an object does rather than how it does it. Question 3. What are the differences between private and public class members? 2 marks, answer. Private class members, these members, attributes or methods, are accessible only within the class in which they are defined. They cannot be directly accessed from outside the class, promoting encapsulation and data hiding. Public class members, these members, attributes or methods, are accessible from anywhere, both within the class and from outside the class. They define the interface through which objects interact with the class. Question 4. What are the differences between data hiding and encapsulation? 2 marks. Answer. Data hiding. This is the principle of restricting direct access to an object's internal data, attributes, from outside the object. It's about protecting data from unauthorized access or modification. This is typically achieved by making data members private. Encapsulation. This is the broader concept of bundling data and the methods that operate on that data into a single unit, a class. It involves both data hiding, using access specifiers like private, and providing public methods, getters, setters, to interact with the hidden data. Data hiding is a mechanism to achieve encapsulation. Question 5. Design a class called cube that has the following data member side data type double. Supply the following methods: a constructor with one argument, a getter and setter method for the side of the cube, the volume equals to side raised to the power 3. Implement the class cube and write a test class cube test in C++ or Java to verify the functionalities of the class cube. 9 marks. Answer. C++ implementation. C++ #include iostream #include cmath // for POW function // define the cube class cube private double side // data member for the side of the cube public // constructor with one argument cube double s. If s equals 0 // ensure side is non-negative. Side equals s, else. Std, count, warning, side cannot be negative. Setting side to 0. Std, ndl, side equals 0. // getter method for the side double get side, const. Return side. // setter method for the side void set side, double s. If s equals 0 // ensure side is non-negative. Side equals s, else. Std, count, warning, side cannot be negative. Side remains unchanged. Std, ndl. // method to calculate the volume double get volume, const. Return POW, side, 3, // side asterisk side. // test class, main function in C++, int main, // test case 1, create a cube with a side of 5.0 cube 1, 5.0. Std, count, cube 1, side, cube 1 dot get side. Std, ndl, std, count, cube 1, volume, cube 1 dot get volume. Std, ndl, // expected, 125.0. // test case 2, modify the side using the setter cube 1 dot set side, 7.0. Std, count, cube 1, after set side, cube 1 dot get side. Std, ndl, std, count, cube 1, after set side, volume, cube 1 dot get volume. Std, ndl, // expected, 343.0. // test case 3, create another cube 2, 2.5. Std, count, \cube 2, side, cube 2 dot get side. Std, ndl, std, count, cube 2, volume, cube 2 dot get volume. Std, ndl, // expected, 15.625. // test case 4, try to set a negative side, should handle gracefully, cube 2 dot set side, -3.0. Std, count, cube 2, after trying negative set side, cube 2 dot get side. Std, ndl, // should remain 2.5. Std, count, cube 2, after trying negative set side, volume, cube 2 dot get volume. Std, ndl, // test case 5, create a cube with a negative side in constructor cube 3, -4.0. Std, count, \cube 3, side, cube 3 dot get side. Std, ndl, // should be 0. Std, count, cube 3, volume, cube 3 dot get volume. Std, ndl, // should be 0. Return 0. Java implementation. Java // define the cube class cube, private double side, // data member for the side of the cube, // constructor with one argument public cube, double s. If s equals 0, // ensure side is non-negative. This side equals s, else. System.out.println, warning. Side cannot be negative. Setting side to 0, this side equals 0. / getter method for the side public double get side. Return side. / setter method for the side public void set side, double s. If s equals 0, / ensure side is non-negative. This side equals s, else. System.out.println, warning. Side cannot be negative. Side remains unchanged. / method to calculate the volume public double get volume. Return math.pow, side. 3, / side asterisk side. / test class cube test, public static void main, string, args, / test case 1, create a cube with a side of 5.0 cube 1 equals new cube, 5.0, system.out.println, cube 1, side, plus cube 1 get side. System.out.println, cube 1, volume, plus cube 1 get volume. / expected, 125.0. / test case 2, modify the side using the setter cube 1 set side, 7.0. System.out.println, cube 1, after set side, plus cube 1 get side. System.out.println, cube 1, after set side, volume, plus cube 1 get volume. / expected, 343.0. / test case 3, create another cube 2 equals new cube, 2.5, system.out.println, \cube 2, side, plus cube 2 get side. System.out.println, cube 2, volume, plus cube 2 get volume. / expected, 15.625. / test case 4, try to set a negative side, should handle gracefully, cube 2 set side, minus 3.0. System.out.println, cube 2, after trying negative set side, plus cube 2 get side. / should remain 2.5. System.out.println, cube 2, after trying negative set side, volume, plus cube 2 get volume. / test case 5, create a cube with a negative side in constructor cube 3 equals new cube, minus 4.0. System.out.println, \cube 3, side, plus cube 3 get side. / should be 0. System.out.println, cube 3, volume, plus cube 3 get volume, / should be 0. Section B, Database Development and Administration. 20 marks. A private university is interested in designing a database that will track its teachers, students and courses. Information of interest includes teachers' names, matricule, telephone, gender, grade, student names, student telephone, student matricule, student gender, student address, student age, course title, course code, course ID and course credit. Each student enrolls in one or many courses. When a student enrolls at the end, he had a mark. Question 1. What is an entity? 1 mark. Answer. In a database context, an entity is a real-world object or concept about which data is stored. It is typically a noun that represents a distinct, identifiable item, such as a person, place, event, or concept. Examples from the scenario include teacher, student, and course. Question 2. List all the possible entities. 1.5 marks. Answer. Possible entities. Teacher-student course enrollment, or marks, to link students to courses with a specific mark. Question 3. What is an attribute? 1 mark. Answer. An attribute is a characteristic or property that describes an entity. It represents a piece of information that is stored about an entity. For example, for their student entity, student name and student address are attributes. Question 4. On each entity listed in question 2, list its attributes. 1.5 marks. Answer. Teacher. O teacher ID, or matricule, assuming unique identifier. O teacher name. O telephone. O gender. O grade student. O student matricule, assuming unique identifier. O student name. O student telephone. O student gender. O student address. O student age course. O course ID. O course code. O course title. O course credit enrollment, or marks. O student matricule, foreign key. O course ID, foreign key. O mark. Question 5. What is an ER diagram? List all the components of an ER diagram. 3 marks. Answer. An ER diagram, entity relationship diagram, is a high-level conceptual data model diagram that illustrates the relationships between different entities in a database. It is used to design and model the database structure by representing how entities are related to each other. Components of an ER diagram. 1. Entities, represented by rectangles. 2. Attributes, represented by ellipses, or ovals, connected to their entity. Key attributes are often underlined. 3. Relationships, represented by diamonds, connecting two or more entities. 4. Connecting lines. Lines link attributes to entities and entities to relationships. 5. Cardinality, multiplicity, notations on the connecting lines that specify the number of instances of one entity that can be associated with the number of instances of another entity, e.g., one-to-one, one-to-many, many-to-many. Question 6. Draw the equivalent ER diagram of that private university using the Crow's notation or Chen notation. 3 marks. Answer. Since I am an AI, I am unable to draw diagrams. However, I can describe the ER diagram using Crow's foot notation for the private university scenario. ER diagram description, Crow's foot notation. Entities, rectangles. O, teacher. O, student. O, course. O, enrollment. This is an associative entity or linking table. Attributes, listed within rectangles or described. Teacher, teacher ID, PK, underlined, name, telephone, gender, grade. O, student, student matricule, PK, underlined, name, telephone, gender, address, age. O, course, course ID, PK, underlined, course code, course title, course credit. Enrollment, student matricule, PK, FK, course ID, PK, FK, mark. Relationships, lines with Crow's foot, notations. 1. Teacher teaches course, one-to-many or many-to-many, depending on specific rules. If a course has only one teacher, teacher, 1, teaches, many, course. If a course can have multiple teachers and a teacher can teach multiple courses, teacher, many, teaches, many, course, this would require an associative entity like teaches. Assumption for simplicity based on common scenarios. One teacher can teach many courses, but a course might only be assigned to one teacher. Teacher, teaches, course, one teacher teaches many courses. 2. Student enrolls in course, many-to-many. A student can enroll in many courses. A course can have many students enrolled. This many-to-many relationship is resolved by the enrollment associative entity. Student, enrolls, enrollment, 4, course. The enrollment entity would have student matricule and course ID as a composite primary key, and an attribute mark. Visual representation, conceptual. Plus 1 teaches, asterisk plus teacher, course plus teacher ID, PK, course ID, PK, name, course code, telephone, course title, gender, course credit, grade, asterisk, enrolls in, star. Plus student enrollment plus student matricule, PK, student matricule, PK, FK, name, course ID, PK, FK, telephone, mark, gender plus address, age plus. Note, the above diagram is a textual representation. In a real Crow's foot diagram, the lines would have specific symbols for cardinality and optionality at each end. For instance, their many side would have their crow's foot symbol. Question 7. Convert the diagram to a relational model. 3 marks. Answer: relational model, tables and attributes. 1. Teacher, U, teacher ID, U, name, telephone, gender, grade. Teacher ID is the primary key. 2. Student, U, student matricule, U, name, telephone, gender, address, age. O, student matricule is the primary key. 3. Course, U, course ID, U, course code, course title, course credit. O, course ID is the primary key. 4. Enrollment, U, student matricule, U, course ID, U, mark. Student matricule, course ID, is the composite primary key. O, student matricule is a foreign key referencing student matricule. O, course ID is a foreign key referencing course ID. Note: if a teacher teaches course relationship is many-to-many, you would also need a teaches table like teaches, U, teacher ID, U, course ID, U. For simplicity, assuming a course has one teacher, and a teacher can teach many courses, the course table could have a teacher ID foreign key. Revised relational model based on common interpretation: one teacher teaches many courses, a course belongs to one teacher. For simplicity: 1. Teacher, U, teacher ID, U, name, telephone, gender, grade. 2. Student, U, student matricule, U, name, telephone, gender, address, age. 3. Course, U, course ID, U, course code, course title, course credit. Teacher ID. O, teacher ID is a foreign key referencing teacher ID. 4. Enrollment, U, student matricule, U, course ID, U, mark. Question 8. Using SQL language, answer the following questions. I. Create the tables of your database. 3 marks. 2. Create the database of the university called UNIV. 1 mark. 3. Insert a student your database. 1 mark. 4. Retrieve the marks of all students in a particular subject. 1 mark. Answer. I. Create the tables of your database. SQL. Create teacher table. Create table teacher. Teacher ID int primary key. Name VARCHAR 100, not null. Telephone VARCHAR 20. Gender VARCHAR 10. Grade VARCHAR 50. Create student table. Create table student. Student matricule varchar 20. Primary key. Name VARCHAR 100, not null. Telephone VARCHAR 20. Gender VARCHAR 10. Address VARCHAR 255. Age int. Create course table. Create table course. Course ID varchar 20. Primary key. Course code varchar 10. Unique not null. Course title varchar 100, not null. Course credit decimal 3. 1. Teacher ID int. Foreign key to link to teacher. Foreign key. Teacher ID. References teacher ID. Create enrollment table. Many-to-many relationship between student and course. Create table enrollment. Student matricule varchar 20, comma. Course ID varchar 20. Mark decimal 4. 2. Primary key. Student matricule. Course ID. Composite primary key. Foreign key. Student matricule. References student matricule. Foreign key. Course ID. References course ID. 2. Create the database of the university called UNIV. SQL create database UNIV. Use UNIV. To select the database for use, syntax might vary slightly based on DBMS. 3. Insert a student your database. SQL insert into student matricule, name, telephone, gender, address, age, values, STU001, John Doe, 6771234 for 56, male, 123 Main Street, City, 20. 4. Retrieve the marks of all students in a particular subject. Assuming mathematics is the subject and its course code is Math 101, SQL select s.name as student name. E. Mark from student S join enrollment E on S. Student matricule equals E. Student matricule join course C on E. Course ID equals C. Course ID where C. Course title equals Mathematics, or where C. Course code equals Math 101. Section C, Web Design. 15 marks. Question 1. Draw a picture of how the following HTML, CSS code will look when the browser renders it on screen. Assume the HTML is wrapped in a valid full page with a head and body. Indicate a non-white background by shading lightly. It is possible that some CSS rules shown will not apply to any elements. 7 marks. HTML. HTML P, hello, P furious smiley div 1 div. Div ID equals div 2 div furious smiley div 3 br 3 div furious smiley div class equals div 4 br 4 div furious smiley span class equals div 4 span furious smiley div furious smiley p goodbye p. CSS. CSS div background color white, border 2px black, padding 1m, body div float right div. Background color cyan, margin 1m, text align right, hash div text decoration underline div. Border 2px solid black, p border 2px solid black, clear both. Answer. Since I am an AI, I am unable to draw diagrams. However, I can describe the rendered output and explain the application of CSS rules. Description of rendered output. Imagine a browser window with a light gray, non-white, background. 1. Hello, paragraph. Oh, this will appear at the top left. Oh, it will have a border, 2px solid black, around it. Oh, the text, hello, will be centered or left aligned within its content box, default. Alignment for p. 2. Main div, the one containing 1, 2, etc. Oh, this div is a direct child of their body, as per the assumption. Oh, CSS rule body, div, float, right, applies, this div will be floated to the right side of the page. Oh, CSS rule div, background color, white, border, 2px black, padding, 1m, applies. It will have a white background. It will have a 2px black border. It will have 1m padding on all sides. 3. Inner div 1 : Oh, CSS rule div, background color, white, border, 2px black, padding, 1m, applies. It will display 1 within a white box with a dashed black border and padding. 4. Inner div with ID equals div 2. Oh, CSS rule div, background color, white, border, 2px black, padding, 1m, applies. Oh, CSS rule hash div, text decoration, underline, applies, the text, 2, will be underlined. Oh, it will display 2 underlined within a white box with a dashed black border and padding. 5. Inner div 3 : Oh, CSS rule div, background color, white, border, 2px black, padding, 1m, applies. It will display 3 then a line break, then 3 within a white box with a dashed black border and padding. 6. Inner div with class equals div 4. Oh, CSS rule div, background color, white, border, 2px black, padding, 1m, applies. This is overridden by .div. For background color. Oh, CSS rule .div. Background color, cyan, margin, 1m, text align, right, applies because of the class selector. It will have a cyan background. It will have a 1m margin on all sides. The text, for then a line break, then for 4 will be right aligned within this div. The border, 2px black, from the general div rule still applies. The padding, 1m, from the general div rule still applies. Oh, CSS rule .div. .div border, 2px solid black, does not apply to this div itself because it doesn't contain a div with class, div, as a descendant. It is a .div, but not a .div inside. Another division 7. Span. With class equals div 4. CSS rule. .div background color. Cyan, margin, 1M, text align, right, applies. It will have a cyan background. It will have a 1M margin. The text, 444, will be right aligned. O being an inline element, span, it will try to sit next to the previous div if there's space, but due to the margin and float on the parent, it will likely start on a new line. O span elements do not typically inherit border or padding from generic div rules unless explicitly defined for span or if the display property changes. The border, 2px-black, from the general div rule does not apply to span. O CSS rule.div. .div border, 2px solid black, does not apply as this is a span, not a div. CSS rule div. The general div rule does not apply to this span. 8. Goodbye paragraph. O CSS rule p border, 2px solid black, clear, both, applies. It will have a 2px solid black border. Clear, both, will ensure that this paragraph appears below the floated div on the right, taking up the full width of the available space. The text goodbye will be centered or left aligned within its content box. Key CSS rule applications. Div applies to all div elements unless overridden by more specific rules. Body div applies only to the direct div child of the body. .div applies to elements with class equals div. #div applies only to the element with ID equals div. Div.div. This rule means a div with class div that is a descendant of another element with class div. This rule will not apply to any of the specific divs as they are not nested in this way. P applies to all P elements. Visual layout summary. The page will have a light gray background. At the very top left, the hello paragraph will appear with a solid black border. On the right side of the page, a large div, the parent of 1, 2, 3, 4, and the span, will be floated. This large div will have a white background, a dashed black border, and padding. Inside this floated div, the words 1, 2, underlined, and 3 will appear, each in their own white, dash-bordered, padded divs. The div containing 4 will have a cyan background, a margin, and right-aligned text, while retaining the dashed border and padding. The span containing 444 will also have a cyan background, margin, and right-aligned text. Finally, at the bottom of the page, below all floated content, the goodbye paragraph will appear with a solid black border. Question 2. Give HTML5 code to create this form, 8 marks. Answer. HTML, doctype. HTML furious smiley HTML lang equals, en, furious smiley head furious smiley meter char set equals, UTF, 8, furious smiley meter name equals, viewport, content equals, width equals device width, initial scale equals 1.0, furious smiley title, H&D student information form, title furious smiley style. Asterisk optional, basic styling for better appearance asterisk, body. Font family, Arial, sans serif, margin, 20px, background color, #F4F4F4, form. Background color, white, padding, 20px, border radius, 8px, box shadow, 0010px rubar, 0, 0, 0, 0.1, max width, 500px, margin, auto, label. Display, block, margin bottom, 5px, font weight, bold, input, type equals, text, input, type equals, email, input, type equals, tel. Width, CALC, 100%, 22px, asterisk account for padding and border asterisk, padding, 10px, margin bottom, 15px, border, 1px solid #DDD. Border radius, 4px, input, type equals, submit. Background color, for CAF50, color, white, padding, 10px 15px, border, none, border radius, 4px, cursor, pointer, font size, 16px, input, type equals, submit, hover. Background color, #45A049, style Furious Smiley, head Furious Smiley body. H1. ND student information H1. Form action equals, method equals, post. Label for equals, name. AME label Furious Smiley input type equals, text, ID equals, name equals, name, required, BR. Label for equals, surname. Name label Furious Smiley input type equals, text, ID equals, surname, name equals, surname, required, BR. Label for equals, birth date. Earth date formatted as DD, millimeter, YYYY, label Furious Smiley input type equals, text, ID equals, birthdate, name equals, birthdate, placeholder equals, DD, millimeter, YYYY, pattern equals, \D, 2, \D, 2, \D, 4, title equals, please enter date in DD, millimeter, YYYY format, required, BR. Label for equals, place _of birth. Place of birth, label Furious Smiley input type equals, text, ID equals, place _of birth, name equals, place _of birth, BR. Label for equals, email. Mail label Furious Smiley input type equals, email, ID equals, email, name equals, email, required, BR. Label for equals, phone. Phone number, label Furious Smiley input type equals, tel, ID equals, phone, name equals, phone, pattern equals, 0 to 9, 15, title equals, please enter a valid phone number, 9 to 15 digits, required, BR. Input type equals, submit, value equals, submit. Form, body. HTML. Section D, networking. 15 marks. Question 1. For the lower 4 layers of the OSI model, give for each 8 marks. I. Functions of the layer. 2. An example of a protocol used in the layer 3. An example of network or interconnection equipment and or end systems used. Answer. The OSI, Open Systems Interconnection, model has 7 layers. The lower 4 layers are physical, data link, network, and transport. 1. Physical layer, layer 1. I. Functions of the layer. O transmits raw bit streams over a physical medium. Defines electrical, mechanical, procedural, and functional specifications for activating, maintaining, and deactivating physical links. O deals with voltage levels, cable specifications, physical data rates, and connectors. 2. An example of a protocol used in the layer. O Ethernet. Physical specification like 100 base, T, 1000 base, LX, O USB O Bluetooth ORS, 232.3. An example of network or interconnection equipment and or end systems used. O hubs O repeaters O cables, Ethernet, fiber optic, O network interface cards, NICs, specifically the physical components. 2. Data link layer, layer 2. I. Functions of the layer. O provides reliable data transfer across a physical link. O handles framing, dividing data into frames, physical addressing, MAC. Addresses, error control, detecting and correcting errors in the bit stream, and flow control, preventing a fast sender from overwhelming a slow receiver. Divided into 2 sublayers, logical link control, LLC, and media access control, MAC. 2. An example of a protocol used in the layer. O Ethernet, MAC and LLC aspects, OPPP, point-to-point protocol, OHDLC, high-level data link control, OARP, address resolution protocol. 3. An example of network or interconnection equipment and or end systems used. O switches, layer 2 switches, O bridges O network interface cards, NICs, specifically the MAC address and framing logic. 3. Network layer, layer 3. I. Functions of the layer. O responsible for logical addressing, IP addresses, and routing data packets between different networks, internetworking. Determines the best path for data transmission. O handles packet forwarding and congestion control. 2. An example of a protocol used in the layer. O. IP, Internet Protocol. O. ICMP, Internet Control Message Protocol. O. IGMP, Internet Group Management Protocol. O. Routing protocols, e.g., OSPF, RIP, BGP, 3. An example of network or interconnection equipment and or end systems used. Reuters O Layer 3 switches. 4. Transport layer, Layer 4. I. Functions of the layer. O provides end-to-end communication between applications. Responsible for segmenting data from the application layer, establishing and maintaining connections, reassembling segments, flow control for specific connections, and error recovery, ensuring all data arrives correctly. Offers both connection-oriented, reliable, and connectionless, unreliable services. 2. An example of a protocol used in the layer. O. TCP, Transmission Control Protocol, connection-oriented, reliable. UDP, User Datagram Protocol, connectionless, unreliable. 3. An example of network or interconnection equipment and or end systems used. O. Gateways, in some contexts, acting at this layer. O. Firewalls, often inspect transport layer headers. O. End systems, servers, clients, running applications that use TCP, UDP sockets. Question 2. What is a network topology? 1 mark. Answer. Network topology refers to the physical or logical arrangement of elements, nodes, links, etc., of a communication network. It describes how devices are connected and how data flows between them. Question 3. For each of the following network give a sketch. 2 advantages and 2 disadvantages, 6 marks. I. 2. Ring. Answer. Since I am an AI, I am unable to draw diagrams. However, I can describe the topology and list advantages and disadvantages. I. Topology. Sketch description. O. Imagine a central device, typically a switch or hub, in the middle. Sketch. Hub, switch, // ABC, // FED, O. Multiple computers, nodes, are connected directly to this central device with individual cables, radiating outwards like spokes of a wheel. O. No direct connection exists between any 2 end nodes, all communication must pass through the central device. Advantages. 1. Easy to install and manage. Adding or removing new devices is simple without affecting the rest of the network. 2. Fault isolation. If one cable or device fails, only that segment is affected, the rest of the network continues to function. Troubleshooting is easier. Disadvantages. 1. Single point of failure. If the central device, hub, switch, fails, the entire network goes down. 2. Cost. Requires more cabling than a bus or ring topology, and the central connecting device adds to the cost. 2. Ring topology. Sketch description. O. Imagine a circular arrangement of devices. Sketch. ++AB. /FC, /ED. O. Each device is connected to exactly 2 other devices, forming a single continuous pathway for signals. O. Data travels in one direction, unidirectional, or both directions, bidirectional, around the ring. Advantages. 1. Orderly traffic flow. Each device has equal access to the network, which can prevent collisions, especially in token ring implementations. 2. Good performance under heavy load. In some implementations with token passing, performance can be stable even with many devices. Disadvantages. 1. Single point of failure. In basic rings, a break in the cable or failure of a single node can bring down the entire network, unless dual rings or fault-tolerant mechanisms are used. 2. Difficulty in adding, removing devices. Adding or removing a device requires breaking the ring, which can disrupt the entire network temporarily.